Hello folks, we are coming to the part 3 video of the exercise 13.2 and we are continuing with the derivatives. It's not by first principles and not being specified. They have just given us some problems on their derivatives. Problem number 5 says that they give us a function and they ask us to prove a certain thing. So let's do it right away. F of x is this function. So consider first f of x to be what is given to us. It is x raised to 100 by 100 plus x raised to 99 by 99 plus and so on x squared by 2 plus x plus 1. I have also in the ready reckoner added this algebra of derivatives that f plus or minus g whole derivative is like taking derivatives of individual terms. You take, instead of taking the whole derivative, it is okay if you take individual terms. So that's what we are going to apply. They are asking us to take the derivative of this whole thing. Now taking this derivative of this whole thing is like taking derivative of each of them separately and then adding them up together. So that is what is the meaning of this. And when the product comes, there is a separate rule. Whenever there is a division, there is a separate rule. So we have to use this rule and get these problems solved. So let's see this. F dash x by formula is this entire thing derivative, that is x raised to 100 by 100, x raised to 99 by 99 and so on, x plus 1. So derivative of this whole thing is taking the derivative of individual terms separately plus x raised to 99 by 99 derivative and so on, x squared by 2 derivative, x derivative, then 1 derivative. So let's find out the derivative one by one. 1 by 100, let it stay here. We know x raised to n, the derivative is n x raised to n minus 1. N x raised to n minus 1, 100 minus 1, 99. Next term. 1 by 99, let it stay because it doesn't go in the derivative constants, they just move out of the derivative. So it's moving out of the derivative, and x raised to 99, n x raised to n minus 1 and so on. Half stays out. X squared will become 2x raised to 1. X, we saw just some time back that x is 1 and constant term doesn't have a derivative, so it becomes 0. But luckily for us, all these coefficients are cancelling. So we are left with x raised to 99 plus x raised to 98 and so on. Last term is x, right? So on the basis of this, we have to find all this. So that is f dash x. So what is f dash 1? Wherever x is coming, there we are putting 1. So 1 raised to 99, 1 raised to 98 and so on. It is, last is 1. Now, it is, and 1 is also there, yeah, x plus 1 is there, right. So, when we substitute this, these are all 1s, 1 raised to anything is always 1. So totally how many terms are there? Till this there is 99 terms and this 100. So there 1 plus 1 plus 1 like that 100 times. Answer is 100. Similarly, let's find out what is f dash at 0. F dash at 0 means wherever x is coming, there you should put 0. So it is like 0 raised to 99, it is 0 raised to 98 and so on, 0 raised to 1 plus 1. So all these terms, they are amounting to 0 and only the 1 is surviving. Is that clear? So therefore, we are looking for 100 into f dash 0. It is 100 into 1 actually. That's 100. Therefore, f dash 1 becomes equal to 100 into f dash 0. We can clearly see it. This is f dash 1 and this is 100 into f dash 0. When we see it, it is very clear to us from 1 and 2 that f dash of 1 is 100 times f dash of 0 and that's what's asked to show. So that's about it. We have used the first, the algebra of derivatives, we have seen it. Now next problem is that they give us this f of x and they give us a function like this and they ask us to find the derivative. That's all, just find the derivative. Much simpler than this. Since they have not defined it, let's define it as fx, x raised to n, a into x raised to n minus 1, a squared x raised to n minus 2 and so on, plus a raised to n, and they ask us to find the derivative. So it's like derivative of every term. It's the derivative of every single term. Yeah. So now let's check. N raised to n minus 1 we know. This is n minus 1 times a x raised to n minus 2. Is it clear? Because x raised to n minus 1, the derivative will be n minus 1 times x raised to n minus 2, because 1 down. Same way, if you want, we can take the next term also. A squared x raised will be a squared n minus 2 x raised to n minus 3. Penultimate term, a raised to n minus 1, x ka derivative is 1, and a raised to n is a number, its derivative is 0. So this is how it is coming. And I don't know, this is what have they asked us. That's it. Nothing much to do. This is the only thing that you can do. This is what the derivative is like. They have asked us to find the derivative. This is how it is. Okay, let's move to this 7th question. Here also they ask us to find the derivative. 3 subparts are there. Let's take the first subpart here. Let f of x be x minus a into x minus b. Now these are products, right? So because we are beginners, we will do it technically, and then later on when we become well versed, we will be able to do directly without all that. So let u be x minus a and v be x minus b. So for our convenience, let's find the derivative of u, then also let's find the derivative of v. What's the derivative of u? X derivative minus a derivative. Derivative of x is 1. A is a constant, no derivative. Then derivative of x is 1, b doesn't have a derivative. So both you have got the derivatives. Now we know by product rule. See, what's the product rule? F into g dash plus g into f dash. That is, whenever fx, we'll have it like that. See, the meaning is when fx, therefore fx is actually u into v for us. So f dash x by that formula is u into v dash plus v into u dash. When u is as it is, you take the derivative of v. When v is as it is, you take the derivative of u. That is a product rule, right? So we have all the elements, we just have to substitute. X minus a is u, b dash is 1, v is x minus b, and u dash is 1, luckily for us. So it's like x minus a plus x minus b. Into 1 means you cannot do much. So it's like 2x minus a minus b. Your answer comes up as 2x minus a minus b. That's about it. Second problem, of course, will come by substitution. I don't know whether I can borrow this place. Right? It comes by substitution. So I'll show you how. Let f of x be this given function, ax squared plus b the whole squared. Right? Already it is so complicated. First of all this, then square. So we'll do one thing. We will call u as ax squared plus b. Okay. This we will call it as u. So what will fx become? This is u now, isn't it? Fx will become u squared. Okay. So u is in terms of x. So let's get the derivative of u. Or if you want, we'll be more specific, du by dx. We also call derivative like that. Let's find the derivative of u with respect to x. So what will come? It is derivative of ax squared plus derivative of b. A will move out. Derivative of x squared is 2x, n x raised to n minus 1. So like that, this will be 2ax. And b, because it's a number, doesn't have a derivative. So overall derivative du by dx is 2ax. F is in terms of u. So let's find derivative of f in terms of u. What will come? Nx raised to n minus 1. So 2u raised to 2 minus 1 is 2u. Now we have got these components. You see, we want a derivative with respect to x. We have not got it properly. We have got f in terms of u, not in terms of x. So let's get it in terms of x. How do we get it in terms of x? Because we have made a substitution, we use something called as a chain rule. What is the meaning of chain rule? That you will have df by du as we have it here, and du by dx will be able to get df by dx. All this we have, so we will substitute. Df by du we have, it's 2u. This is a formula. And du by dx is 2ax. So we have almost got it, except for the fact that u is your creation. So you should not have u, you should have only x's. So u for us, but incidentally is ax squared plus b. So we make that substitution. So your final answer is 4ax times ax squared plus b. Very, very important tool. This is called as a chain rule, by which when we find that a function is very complicated, we make a substitution and we knit one inside the other. That's how it becomes a chain. The f is knitted with u and u is knitted with x, and then together the form of f becomes a function of x, and we are able to get the derivative. So this is called as chain rule. As I said, very important tool. We have to use it many a times next year. This is how we make it by substitution. There's one more part left where we take the quotient rule for this. So that we will quotient rule for finding the derivative of functions. So let's also take that and see how it works. Part 3, question number 7, part 3. Let the f of x be x minus a by x minus b. Here also, for our convenience, we'll calling this and we'll be calling u and v. So let u be the numerator and v be the denominator. By routine, we will find out its derivatives. So x derivative, a derivative, x derivative, b derivative, derivative of x 1, derivative of v 1. Now, therefore f of x is actually u by v. So by function it is v into u derivative, u into v derivative by v squared. So that is v for us is x minus b. Derivative of u is 1 luckily. U for us is x minus a, derivative of v is 1 luckily, and v squared is x minus b the whole squared. Let's solve this. X minus b, and this is all x minus a. So let's solve it. Minus x plus a by x minus b the whole squared. Cancel, cancel. A minus b by x minus b the whole squared. Quotient rule. Yeah, we are solving the answer by quotient rule, and that was our problem number 7. So that should be all for this video. There are more problems left, but that will be taking it up in the next video. Thank you.